Hello everybody, we're getting ready to do 7.5 of Algebra 2 with recursive rules and sequences. And we're going to do part 1. If you need part 2, part 3 of PowerPoints or video, email me here. If you need worksheets, solution PowerPoints, email me here. 7.5, use recursive rules with sequences and functions. Here is our standard here. We have a 38-point skill sheet, and we have no points, 0 points of note-taking here. Teachers, here is your bell work for your students. I would give them write the repeating fraction as a repeating decimal as a fraction. Write each fraction equal to its repeating decimal. So I give them 5 minutes to do this. Okay, welcome back. We're going to correct our bell work now. So for number 1 here, it would be C. The answer would be C. 18.181818. So 18 plus 18 times 0.01. And then we square it, etc. And we get this. We develop a series here. 18 over 1 minus 0.01, we get this number here. We divide that, we come up with 200 over 11. And then write the repeating decimal as a fraction in lowest terms. So we need to write this in lowest terms as a fraction. 32, when we do the same thing here, we determine a series here so we can come up with a where this series is going. So we have a to the first member over 1 minus r. We have 0.01 for this. 1 minus, so we get 32 over 0.99. We get 3200 over 99, and that would be our fraction there. Okay, using recursive rules with sequences and functions. You use explicit rules for sequences. You'll use recursive rules for sequences. So far in this chapter, you've worked with explicit rules for the nth term of a sequence, such as a to the n equals 3n minus 2, and a to the n equals 3 times 2 to the n. An explicit rule gives a to the n as a function of the term's position number n. So in this lesson, you'll learn another way to define a sequence by a recursive rule. It gives the beginning term or terms of a sequence, and then a recursive equation that tells how an is related to one or two leading terms. So for example, evaluate recursive rules. Write the first 6 terms of the sequence. So here is our recursive rule. Here, a naught equals 1, then a to the n equals a to the n minus 1 plus 4. A naught equals 1 is what we begin with, and then a1 equals a naught plus 4. We plug that in here. A to the 0 minus 1 is a naught plus 4 equals 1 plus 4. A naught here equals 1 equals 5. Then a2 equals a to the 1 plus 4. 5 plus 4 equals 9. And then 9 plus 4 equals 13. And then 13 plus 4 equals 17. And then 17 plus 4 equals 21. Here is our second rule here. So b, a to the 1 equals 1. So 3a 1. 3a times 1 is 3. 3a2 is 9. 3a3 is 27. 3a4 is 81. 3a5 would be 243. So let's get our guided practice in here. Students, this one is on you. We're going to do this one right now as a guided practice. Write the first 5 terms of this sequence here. So A2 would equal A1 minus 7 equals 3 minus 7 equals negative 4. And then A3 would be A2 minus 7 be negative 4 minus 7 be negative 11. A4 would be negative 11 minus 7 equals negative 18. Yeah. Then A5 would be negative 18 minus 7 be negative 25. So that would be our solution to that recursive sequence. Arithmetic and geometrics in part A of example 1. Observe that the difference of consecutive terms of a sequence are constant, so the sequence is arithmetic. In part B, the ratios of consecutive terms are constant, so the sequence is geometric. In general, rules for arithmetic and geometric sequences are recursively as follows. Recursive equations for arithmetic and geometric sequences. Arithmetic sequence, here's arithmetic where D is common. Geometric is where R times A to the n minus 1 where R is common. So we have a ratio versus a difference here. That is the difference between arithmetic and the geometric, is the ratio versus the. Okay, so going back to example 2, write a recursive rule for the sequence. Here's our sequence. The sequence is arithmetic with term A. The first term is 3. In common difference, it would be 10. So we plug that in now into our general recursive equation for which part of the sequence, A to the n minus 1 plus 10. Substitute 10 for D. So recursive rule for the sequence, A to the 1 equals 3, and A to the n equals A to the n minus 1 plus 10 is what we come up with there. Write recursive rules. Write a recursive rule for the sequence. Here's a sequence here. Sequence is geometric. First term is 16, and a common ratio will be 2.5. So here is our geometric sequence formula here. So we plug in 2.5, A to the n minus 1. So recursive rule for the sequence is A to the 1 equals 16, and A to the n equals 2.5 A to the minus 1. Okay, our guided practice, write a recursive rule for the sequence. Students, this one is on you. Okay, for the guided practice, here's our sequence. A to the 1 equals 21. And then R equals 14 over 2, which equals 7. So we plug in now. A to the n equals 7A to the n minus 1 for this one. That is part 1 of 7.5. If you want part 2, part 3, email me here. And for other worksheets and for online tutoring, email me here. Thank you.